Hello viewers, in today's class we are going to discuss two important problems related to Dirac Delta function, right? So here in this lecture we'll calculate the value of these two expressions involving the Dirac Delta function, right? And we'll see the properties which will be used to find out the values of these two expressions involving Dirac Delta function, right? So let us start. So now let us take the first expression, right? So here we have a function 3 times cos square 3x plus 2 sine x over 2, and here we have delta of x minus pi, right? So to find out the value of this expression, let us take this function as f of x, right? So if we take this function as f of x and this Dirac delta function as delta of x minus a, where a is pi, so this expression then takes the form f of x delta of x minus a, right, where f of x is this expression and a is pi, right? So now we know an important relation in Dirac delta function, and the relation is f of x delta of x minus a is equal to f of a times delta of x minus a, right? So this is an important relation in Dirac delta function. So f of x delta of x minus a is equal to f of a delta of x minus a, right? So here what we have done, we have evaluated the value of this function f of x at the point x is equal to a, right? So here f of x delta of x minus a is simply f of a delta of x minus a. So we can now find out the value of f of a, and this a is pi, so we have f of pi, and here we have delta of x minus pi because we have assumed that a is equal to pi, right? So f of pi is given by substituting x is equal to pi in this function. So we have 3 cos square 3 pi plus 2 times sine pi by 2, and here we have simply delta of x minus pi, right? So now the value of cos 3 pi can be calculated by this relation from trigonometry, that is cos of k pi is equal to minus 1 raised to k, right? So here the value of k is 3, so we have cos of 3 pi is equal to minus 1 raised to 3, that is equal to minus 1, right? So k is some integer, right? So cos 3 pi is equal to minus 1. So here 3 is an odd number, so cos 3 pi is minus 1, right? And the value of sine pi by 2 is equal to 1, right? So we can now take or substitute the values here. So we have 3 times minus 1 raised to 2, and here we have 2 times 1, right? And here we have delta of x minus pi, so this is minus 1 square is 1, so we have simply 3, this is 3 plus 2 delta of x minus pi, so this is 5 times delta of x minus pi, right? So the value of this expression is equal to 5 times delta x minus pi, right? And always remember that to calculate the value of these kind of expressions, we can use this relation. Now let us take the second problem, right? So here we have x square minus 5x plus 3 and delta of 3 times x minus 4. So what we will do here, Here also we will apply two important relations from Dirac delta function, right? So the first one is the relation which we have used in solving the first problem here. So f of x delta of x minus a is equal to f of a delta of x minus a, right? So this will be the first relation, and then we'll make use of this important uh, property of Dirac delta function, that is delta of ax is equal to 1 over the absolute value of a, and here we have delta of x, right, where a is not equal to 0, right? So see, here we have delta of 3 times x minus 4. So here we can slightly modify this property to delta of, say, lambda times x minus a is given by 1 over absolute value of lambda, and here we have delta of lambda times x minus, here we have simply delta of x minus a, right? So we have modified this property to this one, and here also lambda is not equal to 0, right? So these two properties will be used to get the value of this expression, right? So here this function can be assumed to be f of x, and here we have delta of 3 times x minus 4. So the value of lambda is equal to 3, and the value of a is equal to 4, right? So now this expression can be written as f of x, then we have delta of lambda times x minus a, right? So using this property, we can now write f of x and 1 over that is absolute value of lambda delta of x minus a, and this is 1 over absolute value of lambda f of x, and here we have delta of x minus a, right? And f of x delta of x minus a can be replaced by f of a delta of x minus a, right? So we can have here 1 over mod of lambda, and here we have f of a. Using this property, f of x is now replaced by f of a, and here we have delta of x minus a, right? Now see, lambda is 3, so we have mod of 3. So mod of 3 is simply 3. So we have 1 over 3, and f of a is f of a is our 4. So here we have f of 4 and delta of x minus 4, right? So now we need to find out the value of f of 4. So now f of 4 can be obtained by taking x is equal to 4 in this expression, right? So f of 4 is 4 square, then we have minus 5 times 4 plus 3. So this is 16 minus 20 plus 3. So this is 16 minus 20 minus 4, and this is 3, and this is minus 1, right? So this f of 4 may be replaced by minus 1. So we have now the value of this expression is equal to 1 over 3 times minus 1. Then we have delta of x minus 4, right? So this is minus 1 over 3 delta of x minus 4, right? So the value of this expression is equal to minus 1 over 3 delta of x minus 4.